This is me, Ochen from Nerdimations, and today I'm going to show you how plates tectonics work. Now, I have a question for you. How long has it been since you sat your bum down into science class? Now, for you, that was like a few years ago at minimum. For me, it was 12 hours. Now, I have a big knack for science, which I haven't shown yet. And today I'm going to educate you on what you probably didn't learn in most of your geology stuff. And also thanks to the Concord for Tectonic Explorer. And we're going to use the 5-plate uneven distribution for this one. Because the more plates, the better. And also 2-plate will just always be a problem. Okay, well, we're going to start with plate number 3 being mostly continent. Okay, you can't exactly make it a continent. And then we'll have, I'll say a continent between plate number 2 and plate number 4. Now, in real life, this wouldn't exactly happen. Back in the early Earth, what would form the continents were called cratons. For example, there is the Canadian Shield, or the Laurentian craton, which formed due to a ton of volcanoes exploding all about the same time. I'm making a big shelf that basically anything, that allowed land to sit on it, and it would become the basis for our continents. Some other examples are the Baltic craton, which is the foundation for Europe, the Amazonian craton, and I think there's one around Argentina too, which of course makes South America, and the Congo craton, which forms Africa. Okay, I think that's good. Now, the boundaries. We're going to have plate 1 diverge from plate 3. We'll have convergence here, and divergence here. Okay, good. Now we have to order them by their density. Lower density plates are continental plates because they're mostly made out of stuff like granite. Granite will most likely float over oceanic plates, which are made of basalt, which is denser. This will cause subduction, and we'll see it later. I don't really know which plates are which, so we're going to continue. Dang, that was fast. Okay, let's quickly go through for the first few moments of this. You can see block mountains forming from this rift. This is because they're being spreaded up and out. These, and if you turn it to crust stage, oh wait, it's not. This is another rift. This rift, as you can see, is the crust here is new, and if you turn back to top of the graphic, we can see that a rift is forming here. Okay. Tectonic plate number 3 is suffering here. But I guess that's what happens when you're always the smaller plate. I'm going to show y'all all the tectonic plate boundaries. So even with the topographical map, you can see them. It seems that all the continents are moving in one. Oh, cool. As you can see, once a rift forms big enough, a new plate will be born. This is something you'll see in quite a few places. This is where land separates. When a piece of land separates from another piece of land, once the area becomes big enough, new plates will be born. This is what has happened in the mess that is called the Pacific Islands, where the Pacific and Australian plates ram into each other or ram away from each other. As you can see, it happened again. These plates commonly are just small lines, which is why when I turn it to plate color, you can barely even see that where plate 7 is. But give the plate a little bit of time, and it will grow. Let's see plate 6. Oh my god, you see? Plates will show up. Will continuously show up. There's plate 6 and plate 8 already. And now, let's do something. Let's take a cross section. Oh god, yeah, as I said, these plates will pop in, and don't expect them to slow down speed. Also, here's something odd you'll see. What did plate 7 do? It seems that the plate boundary that plate 7 sits on has been moved, and so the plate boundary is not doing very well. Well, and there's space where the plate boundary stays together, which seems to have been rendered by the computer model as more parts of plate 5. The same kind of thing has happened between in Eurasia and Africa. The Atlantic sections of their plates don't actually have a boundary. So commonly, you'll see them see either plate boundary, even though they still have the boundary further into the Mediterranean, will be shown as a straight line. And let's see what has happened to plate number 3. It seems that plate number 3 is now going extremely fast, which means that even though this plate number 5 is coming towards it, there's still a rift forming. And something interesting is these islands. I think, is the perfect place to draw a cross section. And here we go. From the top of these mountains. Good dang, I could have made it bigger. Wait, let me try again. From this valley to this valley. Now. And now let's turn to this side. where wait a second, this is D and C. We have to turn to B and A. If you see B and A, you'll see. Now let's open this seismic data. No map type. And here it is. Keys for rock types. As you can see, there's the weaker metamorphic rocks, and then there's the stronger ones. Meanwhile, everything around is granite, the stuff that makes these continental plates. There's some sandstone on here, and you'll see the continental sediments on the top with these cliff-like thingies where the elevation just suddenly drops. I'm not sure if that part is accurate. Now, if you turn here to C and B, we'll see there's a gabbro and basalt. The gabbro is further down, and the basalt is above it. I can't exactly tell what this is. It looks like a mix of gabbro, diorite, right, or something else, but I really just can't tell. And it seems that here the magma is breaking out, or at least it's soon going to break out. Here's what I think probably happened to some of these islands. And also you can see once again the subduction here, where one of the plates is sinking into the other, where it's slowly turning from basalt and gabbro into metamorphic rocks. And this is also probably accelerating the speed at which that subduction happens. Cool. Let me check. There's a good chance that probably soon a 10th plate will show up out of completely nowhere. Just a patient. It seems that plate number 7's boundary is beginning to weaken. Even though you can see the massive rift that it's created. Just like the massive rifts that are created in gamers' foreheads due to headphones. Wonder which ones this one was using. Plate number 4 is trying to kill plate 8, 6, 11, and 13, and 12. Where's plate 10? Or was it almost immediately extinguished? Okay, it was probably almost immediately extinguished. You probably find it soon. That probably wasn't. This seems to be extremely messy. Now you can see that this is starting to actually resemble all the Australian and Oceanian and Pacific plates coming together. Going apart, I mean. But with all these plates, it's forming out of them. There was almost the plate 14, I think. Let me see if they're rendered. No, they're barely rendered as. What trickery is this? What is this? I'm just not gonna ask. Yes, plate 7 is by the simulations and count isn't having a good time. And I would see Rock Age. You can see here that the rock is still pretty old because it seems that the divergent boundary is over and now all these plates are getting crushed. Except over here where they're forming again. Now, plate number 11 was the only one that survived in this area that survived the plate massacre. Oh God, plate 15. It seems that the new messy area is here. Here, as you can see, this rock is extremely new. Let's see the rock types, or at least the surface rock types. This is continental. This is oceanic, and I think these are sediments, continental and oceanic sediments with sandstone on around here. Okay, let's stop. Altogether, I think we've created an awesome seismically active world with these mountain chains, like the 4 mountain chain. Look, I can't have better names, okay? And massive trenches. Anyways, thank you. This is Nerdimation, and goodbye.